This is a video to show how these chemical raising agents are used in baking and why they're used in baking and how you can develop your cooking skills to utilize these fantastic ingredients. I'm now going to demonstrate these chemical raising agents using scones. So I'm going to use each of these three chemical raising agents in the scones, but I'm going to use plain flour because this self-raising flour is essentially plain flour plus the baking powder. So this plain flour and this baking powder make this, but we're going to use the plain flour with all of these so that we get a nice even test, and it shows how much or how little these scones are going to rise using these three different chemical raising agents. Here we have bicarb of soda. This is the pH scale, so this is an acidity scale. So we go from acidic and we go all the way up to alkaline. Bicarbonate of soda is here. It's in the alkaline area. It's got that kind of soapy taste to it. And within the same bracket as alkaline, you have such things as like drain cleaner and bleach. It's also, you can use this as a cleaning product as well. What I have here to demonstrate how this reacts with products is an acid. So this alkaline here on the scale needs an acid, which is all the way down here, to then create carbon dioxide. So here I have a spoon and watch the reaction. Due to its soapy taste, it needs then to be used in stronger flavoured cakes, such as gingerbread, to hide that soapy taste. On the other end of the scale, the acidity scale, we have cream of tartar, which is a byproduct of winemaking. And in this glass, I've got some cream of tartar. So being acidic, I'm going to add the lemon juice again. So an acid with an acid. I'm just curious as to whether this would create CO2 to help with cakes. So you can see that from this reaction, that's completely different from the bicarbonate of soda. This is one we'll all recognize, baking powder. Now, interestingly enough, the way that these three come together, we have an acidity of the cream of tartar. We looked at the other end of the scale, of the pH scale, for the alkaline, which is the bicarb of soda. You put cream of tartar and bicarbonate of soda together, mixed with a little corn flour, we end up with baking powder. So essentially, this is completely now neutral, having the acid and the alkali coming together to neutralize to then make baking powder. So essentially, you've got the soapy taste and the acidic taste then being neutralized, and then we have baking powder. So again, with our lemon juice, just to show you the reaction. The CO2 is released. It's not as vigorous as it was with the bicarb, and the acidity from the cream of tartar is helping to stabilize it. Therefore, baking powder is one of the perfect ingredients and a nice chemical reaction for use within cakes. The scones have now been baked, and as we can see, there is a considerable difference in the results. To give you an idea of what a scone looks like without a raising agent, it's this. It's the one that used the plain flour. So I've just baked one just with plain flour. And I can tell you now that it's not got a lot of colour to it. You can see where it's not cooked as well. Like there's doughy parts in the scone. You can see there's been no rise in there. There's no considerable gas that's been produced, no CO2 to help it to rise. It feels heavy. And when you would eat it, it would just taste doughy, uncooked, and just a flat flavour. So this one, it just feels chewy as well. It's just tough and horrible, basically. So that's just plain flour by itself. And this is because plain flour on its own does not contain a raising agent. The scone with the cream of tartar, so this looks like the scone that had no raising agent in it, and we can see just even by breaking open this one, it pretty much looks the same as the one that without just the plain flour. So you can see there's probably just a slight rise in there, but this would have the taste also of, it would have like an acidic taste, because we must remember that cream of tartar belongs down here on the pH scale. So it's an acidic chemical raising agent. So you can see there, not much of a rise, and it looks pretty much the same as it did when it doesn't have a raising agent in it. The scone with the bicarbonate of soda, we can see that that's quite very golden brown. It's got a nice brown to it, but on a closer inspection, it does have a green tinge to it. There is a green look to it. It rose really well. You can see there that a lot of CO2 has been produced. There's been a good rise in there. But the thing is, with this, it would taste soapy because it has a high alkaline content. Remembering here that bicarbonate of soda is up here in the alkaline scale, so it's here, giving it that soapy taste. So this is why it's used with stronger flavors like ginger, fruit and chocolate, so to hide that soapy taste. The scone with the baking powder has also risen well with a slight golden brown colour. But what would be the sensory outcomes of this scone due to using the baking powder, and why? The scone with the baking powder would taste light, sweet and fluffy with no acidic taste or alkaline taste, because it is a mix of both cream of tartar and bicarbonate of soda, and those neutralise the flavours of the acidic and the alkaline, thus creating a pleasant looking and a great tasting product.